I'm going to kick off with a very high level view of the Safe network. The Safe network is massive. I think hopefully you will agree in kind of vision and in the things that we're doing. So what I'm going to do is throw out a few concepts, throw out a few terms, and hopefully that will give people something to dig into later. So specifically avoiding parsec, because that's what the guys are going to go into in some greater detail. So when we think back to, I don't know, you've no doubt heard this story back in 48 BC when Caesar and his troops burnt down the Library of Alexandria. There was some estimate that it was about 40,000 books were destroyed at that point in time, which would have been pretty much most of humanity's knowledge in book format. We need something, we need a way of saving documents, we need a way of saving books, we need permanent data. We don't have that today. Now, there are a number of problems that we're trying to fix, that many people are trying to fix. I just want to run through them very quickly because I only have, as I say, about 15 minutes and lots of slides, unfortunately. The first one is, where's your data belong? Most of the time, we save our data on personal computers, which break, or more likely we save them on cloud services. We're giving them to third-party institutions. It's a piñata for hackers. We all know this. There's an issue with that. Sorry, my clicker isn't really working. So as a result, we get things like the Dyn DNS issue, whenever that was, 2016, when all the Mirai bot basically brought down a huge number of the websites around the world, the heavily trafficked websites. We also just have too many humans. And what are humans? Humans are fallible. They're always making mistakes. So you'll get things like the Dropbox hack, where there was an employee who logged in using his LinkedIn password, same password that had been hacked previously, and that affected how many? Some insane number, 68 million accounts or something. And then you have the people that have to build these servers, massive databases, or centers. It costs a fortune, in terms of how much money these companies, whether it's Google or whoever, has to put aside to be able to plan in terms of capital expenditure. And at the same time, we've got this massive tsunami of data through the Internet of Things, through all the other self-driving cars, whatever it might be. We're walking into this situation where we really need to get all this stuff sorted out one way or the other. And on top of that, we then have the whole surveillance capitalism, as it's called. I don't think I need to go into that. I certainly don't have time to go into it. But it's pretty clear that we've built an internet, or we have an internet today, which is driven for the most part by tracking and clickbaity kind of content, which I don't think is doing anyone any good whatsoever. That's before we even touch on privacy. That's a whole topic in itself, but let's be honest, everybody needs privacy. Everybody is walking into a bit of a nightmare on that one. So the summary is that we have a lot of problems and we have a lot of data. And a lot of these issues that I've just touched on there are all actually related to one thing in particular. No, not ants, it's putting it in these centralized locations, these massive buildings, okay? Now, take a step back. Let's have a look at nature. So when MadeSafe was founded, the founder, David Irvin, actually incorporated the company in 2006, but was looking at different solutions before that time. And he's always been very inspired by nature, and you'll see this coming through a lot of the documentation and blog posts and everything over the years. If you go into nature and you look at how decentralized systems deal with efficient workplaces, ants are a fantastic example. Take an ant colony, so many ants, and every single ant could be a forager, a food carrier, a cleaner, a soldier, doesn't matter. They all walk out the colony at the start of the day and they might have their soldier hat on, and they meet somebody and they sense with their antenna how many other ants there are. There's too many soldiers, so they suddenly swap what they're doing. And this is the concept of this autonomous, decentralized organization responding to the issues that is faced. Now, this is slightly controversial given where we are and what we're talking about. But there is a lot of hype, I think we would all agree, around what blockchain technology can be and can do. So the question is, can it actually deliver on many of these things? A lot of people, when they look at MadeSafe, because we've been around for a while, we've always been in the same group, decentralization, cryptocurrency, etc., assume we have a blockchain. We have no blockchain. Public disclosure. I think we've always been open about this, but I think sometimes that message doesn't necessarily come through. And why is that? Because for what we're trying to do, which is build a next generation of data and communications and a decentralized network, the unfortunate facts are that a blockchain doesn't provide us with that sort of scalability. The reason, or many reasons, one of them is that a lot of the blockchain solutions you'll see today simply have pointers. Those pointers lead off the fantastic blockchain capability to record a ledger, to show transactions, to show that something has happened. It will then point off to the data which is stored in another location. That location tends to be off-chain, tends to have a huge amount of data if we're going into this new world. And how do you secure that? Because that's not being secured by the blockchain. The blockchain isn't keeping the data honest, and this is a vital point. So it's kind of poor mass storage, as we all know, in terms of read-write performance. It's fantastic for lots of things. So we're not slagging off blockchains. We just want to get something that actually is right for the purpose here. So we share all exactly the same views of what decentralization is, what the benefits could be, but we do have a different path to get there. So, what is the Safe Network? Safe Network, that's a simple way to describe it, the world's first autonomous data and communications network. There is a lot in that though, so I'm only going to fly through a few of these concepts. But there's fully encrypted data storage. So all data going onto the network is permanent and it is encrypted by default going on. You can override this if you like, but that's the big difference with today's internet, where the internet was built to be connected. It wasn't built to be secure. There's also anonymous logon, I'll come on to that. There's no service, as I've said, and we have a cryptocurrency built in terms of a utility token on there, and that provides for anonymous exchange of value. But again, no blockchain. So the first question is, well, how do you actually log into it? There's no servers, there's no centralized authority. And this is the concept of self-authentication. This is the thing that so many people probably don't necessarily think about when they think about decentralizing the web. If you can't log in securely without a central authority holding your credentials, you haven't decentralized the web. That's working today. So let's start speaking about the data. How do you secure it? Well, there's a concept of self-encryption. Again, I'll go into this in questions and beers afterwards. Self-encryption is you upload the data, it's split into chunks, it's all encrypted with itself, and then it's fired off all around the network. So you upload it, it's self-encrypted, it's then every piece of permanent data that is uploaded creates its own address, if you like, using the XOR system. That's then located at a specific place around the network, and only the owner can ever decrypt that. I'm going to have to rush through a lot of this. It does mean that we get the benefits of data deduplication, i.e. if you've got a PDF and there's 1,000 copies of that on the internet, you don't need 1,000 copies of it. You just need to make sure that those 4, or whatever that number is, of copies are there and they're permanent. So they can be pulled back in the future when people are accessing it. Vaults. Basically, vaults are where people are storing data on their own computer. And this is the idea. So it's a decentralized internet where you run your own vaults. You run your own computer program, and you take part by letting people store some of their data that's encrypted in pieces on your actual machine. I can go into this, but I suggest we do it again at beers. We've got a thing called Crust. Crust is the communications, the way, it's a software library that enables communication on the Safe network, is the easiest way to describe it. So what's good about it? Well, a number of things, but one of the main things is the whole punching. We've got support for different protocols, TCP, UDP. It's then got the BitTorrent UTP to provide the reliability in terms of the data. And it's also, because we've got NAT traversal, we're able to get in through, I'm not going to tell a room full of developers this, but we're able to get in through firewalls and routers, etc., to create that peer-to-peer connection. But why do people want to join in the first place? Why do they want to do anything? It's because of incentives. What are the incentives? Why would you want to be a farmer? And the reason is because you get rewarded if you're storing data that is then subsequently returned, or a piece of data that's returned. I'll not go into that, it's fairly obvious. It's a circle. You store stuff, it gets requested. Somebody will request that data, and it's free to browse the network, and you get rewarded. for the data that's returned. Safecoin itself is the utility token. It's anonymous, it's near instant, it's basically network speed and there's no fees involved. It's basically a form of data on the network. But this is kind of more interesting for how does an autonomous network actually, what is it? Why do we call it autonomous and why is it important? Well, it's important because once it goes live, basically the network is making all the decisions itself. It's making a decision about the resource proof. If a node is trying to join the network, does it have the capability, does it have the capacity, the bandwidth, etc., to join and be a valid citizen of the network? Then once that node joins the network, it's managed to connect through bootstrapping to another node that's already on the network. It then gets introduced to another node somewhere else, somewhere around the world. It has no way of deciding or choosing which section it goes into. And this is vital because it means that as soon as you start to try to attack the network, which inevitably will happen, you don't know where you're going to end up. I'm not going to go into data chains at the moment because it's too big a subject, but it's basically a single ledger that records all the transactions that have taken place in a section. But we'll go into that later. As I accelerate through this, one other thing I want to leave you with is this idea. People have spoken about the semantic web for a long time. But this idea of being able to have data that is yours, like think back to Facebook and Cambridge Analytica. I think we all know this. How many Facebook have, whatever percentage it is of the world's population? Would all of those customers stayed with Facebook when that sort of scandal erupted, if they'd had the option of simply deauthorizing Facebook and clicking onto not Facebook, where all their friends would be, where all their data would be, all their likes and all their activity? I suspect not. I think Facebook might have been in trouble. But this is exactly what Tim Berners-Lee, through the Solid project, is talking about when it comes to linked data, and when it's combined with the safe network, as it has been. At the moment, we're working through different proof of concepts, working with the Solid people within the Solid community. We've got Pata, which is in no way a rip-off of Twitter. But you could turn it off and click onto not Pata and all your data's there. So the concept of an app purely being the goggles with which you view your data, you continue to own that data and you can move around. That fits nicely onto the safe network. No time to go into that, but hopefully if I flash it on the screen to a lot of people who are developers, it will make a little bit more sense. The guys will be speaking about routing, depending on which country you're from. I've touched on Crust in terms of the communication, and we've touched on vaults, but there's all that as well, which is there to be dug into. It's obvious, I hope, but if it's not, it's all open source, and it's utterly crucial to what we do. We are in no way looking to build this as some kind of shady ICO, get loads of money, etc. No, this is an open source project. You can go and have a look at it, you can download it, you can play around with it, you can join the community to get involved, because ultimately it is for everyone, and as soon as we start to restrict that, that kills our main view of what we're doing. Final couple of slides, roughly in time. We can think a lot about all these crypto communities, decentralized communities. How are people coming together and what are they actually achieving? Are they incentivized by money? Are they incentivized by a mission, freedom, whatever it might be? It doesn't really matter, but there do need to be stories that bind people together. And the stories now are being written. If you think back to last year, 18 months ago maybe, do you think we would have had an HBO series talking about decentralized web, talking about cryptocurrency, etc.? I think we're all here in this room it's evidence of the fact that this change is coming. So it's an exciting place to be involved. And that's it. That's about as fast as I can go through the safe network. So apologies if it's. Thank you.